The last part of this chapter is talking about the complex power, and the complex power is measured in VA, voltage ampere. So it's not in watt; it is voltage ampere. It has real and imaginary. The real is in watt. This is what we have. The real, the power, P. So see here where it is here. So yeah, it is S. They call this S, and it is P plus JQ. So it has real and imaginary. P is a power that we know. This is in watt. Okay, so it is a product of the root mean square value, phasor of the complex conjugate of the root mean square current. Okay, as shown here. So it is S called S equal 1 over 2 V time I conjugate. This is a complex power. Okay, so we can calculate it like this: V root mean square time I root mean square conjugate. So you can do that. So when you calculate it, it will look like this. It will have the real power and the imaginary power. The real power, this is the average power, which you know. This is V root mean square time I root mean square cosine theta V minus theta I. So we know this part here. This is what we call it a power factor, remember. Theta cosine, the difference between phases. This is the power factor. And the V root mean square time I root mean square is the same like 1/2 V maximum time I maximum. It is the same. There is no difference. Because theta V root mean square is V maximum divided by square root of 2. And I root mean square is I maximum divided by square root of 2. That is the same. Okay, so you can rewrite this like this: 1/2 V maximum time I maximum. And the imaginary part is J. Again, you can rewrite this like V maximum time I maximum divided by 2, sine the difference. So here you have sine, here you have cosine. Okay, this is the real and this is imaginary. So you can plot it like this. This is the real and this is the imaginary. Then you have this S and it has a certain angle theta here. We call this theta. Okay, so theta is what? Theta is this one here. The angle is the difference between theta V and theta I. So from this plot here, theta actually, cosine theta is the power factor. Sine theta is a power factor, which is P divided by S. P divided by S. And sine theta is Q divided by S. Okay, Q divided by S. And for this example here, we have the voltage this is a voltage, okay, and the current is this. Here it is. We need to find what? Find the complex and average power. So we just use a formula: S equal V root mean square time I root mean square conjugate. So here is the voltage. The voltage is 60 and -9 and -10. So 60 divided by square root of 2. This is a root mean square. 60 divided by square root of 2, angle is -9, -10. For the current, it is 1.5 divided by square root of 2, and it's supposed to be positive here, but because it is conjugate, then it has to be negative. Okay, we make it negative here. Then you just multiply this. Of course, 60 times 1.5, we know this 90. 90 divided by 2 will be 45, and -10, -50 will be -60. Okay, so this is S. This is S. So we know that this angle here, this is a angle. This is a difference in phase between V and I, and cosine this angle is a power factor. So if you want to calculate the power factor, it is cosine is -60 degree. Or also you can calculate it from here. I know this one is -10 here, -10 theta V, and theta I is is 50. So the cosine, the power factor is cosine -10 minus 50, which is cosine -60. So this is a power factor. So you can calculate it from here. You can calculate it from the regular form. That's fine. That's fine. So here's the complex and the average power. We need to find the average power. So we have to convert this to real and imaginary. This will be the average power. This part will be the average power. So it will be 45 cosine this angle, okay, and then here minus J, of course, because it will be, or plus J cosine -60, and sine -60 would be negative, of course. So this is the real part, and this is the imaginary part. The real part is the average power. Where is it? It's the average power. The average power. So the complex, this is a complex here. This one or this one. This is a complex. The average power is this 22.5. The real and reactive power, here it is. Actually, I don't know why we have two here. Complex and average powers. We have them already here. So it is repeated. Anyway, so power factor is already here, as I said before. And the load impedance, if you want to find the impedance, it's just V divided by I. It has no relation with power, actually, but just for you to practice on calculating the impedance. So the impedance equal what? V divided by I. 60 and negative 10 is 6 and negative 10 divided by I, which is 1.5 and positive 50. Then this will be the impedance. So as you see here, the impedance, if you convert it to real and imaginary, it will have a negative imaginary, which means that it is a capacitive load. The last part here is about correction of the power factor. What's the meaning of correction power factor? We assume that you have, for example, some devices like washing machine, like air condition, like refrigerator, motors. Most of all of this actually are actually inductives. They have inductors. Okay, so they have inductive load. Okay, so if you want to look at the power factor, the power factor is so low. So we need to, as designers, as engineers, we need to improve the power factor to let them have more power. So to do that, because if they are purely inductive, then you will not have any power. The power will be zero. So what we need to do here is to improve the inductor. Here, for example, assume that you have this is inductor and has some resistor, of course. Okay, so this is a total here, so it will have some power factor. But to improve it, you can add a capacitor here in parallel like this. When you add a capacitor, then this will balance little bit the inductive load. Then in this case, you can decrease the imaginary part, and you will have more real part. So how can we do that? If you look at this triangle here, this is a power. Okay, this is a real power for the resistor. And then you have imaginary power, which is Q1 here, this one. So in this case, this is S1. So in this case, theta 1 is the original, cosine theta 1 would be the original power factor. So to improve the power factor, you have to decrease this angle. You have to decrease this theta. So you have to move this S in this direction here. You have to decrease Q. Okay, how do you decrease Q? Okay, so you have to by adding this capacitor here. You have to add this capacitor. So we need to know what is the value of the capacitance that we need to add to improve the power factor to a certain value. And to do that, you have some equations here. Some simple equations. This Q1 equal what? Q1 equal P tan theta 1. You know this. This is Q1 over P is tan theta 1. So Q1 is P tan theta 1. And the Q2 is P tan theta 2. Okay. So the capacitance here equal what? Equal this QC is the difference between them. Okay. Divided by omega V root mean square. This is the equations that we use to calculate this C. Okay, so if you want to improve the power factor to a certain value, this is how we do it. And this QC is the difference between Q1 and Q2. Q1 is this one here, Q2 is this one here. So of course you can take P outside. So it will be tan theta 1 minus theta 2. Okay, so if you know, for example, if you have original theta 1, and you want to improve it to certain one, which is theta 2, which is less, to improve the power factor, then in this case, you need to add a certain capacitor or capacitance here, C. How do you calculate it? Use this equation. To explain this more, let us take this example here. Assume that we have a load connected to what? 120 volt, root mean square value, and 60 volt, 60 hertz. By the way, this is the voltage that we have in the United States. We have 110, almost 110 volt, usually, root mean square value. So 110 is not the power, the maximum, it is the root mean square value. So the maximum is 110 times square root of 2. So this is the voltage. and it absorbs 4 kilowatt. 4 kilowatt, this is what? This is P. This is P, this value here. P is 4 kilowatt. So this is a power, absorbed power, 4 kilowatt. At a lagging PF, so PF is lagging, this means that this inductive load 0.8. So the power factor is 0.8. Power factor is 0.8. Okay, so this means tan theta 1 equal 0.8. Tan theta 1 equal 0.8. Okay, so we see here. No, sorry, cosine, but the power factor is cosine. So cosine theta 1 equal 0.8. So from here you can find theta 1. Find the value of the capacitance necessary to raise the power factor to 0.95. So we need this power factor to increase from 0.8 to 0.95. Then how can we do that? Okay, so let us see here. The power factor was originally what here? Cosine theta 1, which is 0.8. So this means that theta 1 is cosine minus 1 negative our 0.8. So 0.8 inverse cosine. Here is the angle 36, 36.87. Okay, so this is the original angle, theta 1. If you want to improve it to make it the power factor 0.95, then in this case, the angle will be what? 0.95 inverse cosine is 18.19. So this is the angle, the desired angle. So I want to change this angle theta from 36 to 18, almost half. So how can we calculate, or what is the value of the capacitance? We can just use this equation here. C equal what? Equal P, which is 4,000. Okay, so it is 4,000. 4,000. Tan theta 1, we know theta 1, minus tan theta 2, we know theta 2, over omega. Omega is what? 2 by F. F is for 660, 60 hertz. 2 by F. 2 by times 60. V root mean square value is 120. So 120 square. 120 square. So if you want to calculate, here it is. Okay, so let's calculate this. So again, P is 4,000 time open bracket, and then theta 1 is 36.87, and you hit 10 minus 10, the other angle 18.19, 10, okay, equal, just close the bracket. Okay, so this will be the numerator here, equal, this is the numerator, and you divide this by what? Divided by omega, which is 2, okay, by F, which is 60, divided by 120 square. 120 square equal 3.1. 3.1 to 10 to the power of negative 4. So this is the capacitance here. 3.1, 10 to the power of negative 4 farad. Okay. So I believe this is what is required. Find the value of the capacitance. Yes. So this one is 10 to the power of negative 4. If you want to change it to 1, for example, so this is the maximum. Can we do that? I don't know. Let's see. So assume, for example, that you need to change this to 1 instead of, let's change the problem. So assume that this is 1. I don't know if we can do that or not. So let's see here. Then in this case, this will be 1. And I know cosine 0 is 1. So theta 2 will be 0. So let's see if we can do that. Then in this case, what is C? C will be 1. I believe this will be the same. Is it the same? No, it was the same. So it will be P, which is 4,000, time, open bracket, and then tan theta 1, which is 36.87, okay, 10, minus what? Tan 0, we know that tan 0 is 0. You don't have to calculate it. Then you can close this. Okay, so it will be equal, or what's this? 4,000 again, 4,000 time, open bracket, 36.8710. Okay, then you close the bracket here, equal Here it is, 3000, still 3000 and something here. Okay, this 3000, I don't know, it doesn't make sense. Let's see again. Here it is, 3000 again. No, it was 4000, not 3000. It is 4000 time 10, 36.87, 10 equal, here it is, 3000, yes. Okay, so this is a numerator because tan theta will be 0, tan theta 2 will be 0 because tan 0 is 0. Divided by, of course, you can make a bracket here. You can put a bracket and then 2 time omega time b time pi time f time vm v root mean square. You can do that, but you can just use divided by. You can just repeat divided by. So divided by what? By 2 divided by pi, where's pi is here, divided by the frequency is 60, divided by 2 pi f 120 square. Okay, and you say equal. So this actually the capacitance. So if you add this capacitor here, 5.5 10 to the power of -4, you will eliminate theta at all. So in this case, it will be purely resistive. And I believe that this will give you the maximum power at that time, the maximum power. Okay, so I believe this is the last problem in this chapter. This will be the assignment. The assignments consist of 4 problems. These 4 problems are already solved. So what you need to do, just to please try to understand them. And if you have any question, let me know in the live lectures. Thank you very much for watching. Have a nice day.